Ouch.
Are you okay?
I fell. I got a boo-boo and it hurts.
Here, let me put a band-aid on that.
Hey, why does my boo-boo hurt?
Well, basically, your body is made of tiny things called cells. Each of these cells have their own job to do. Some of these cells are called pain cells, and their job is to tell the brain every time something bad happens to the body so that the body can stay healthy. The brain gets the message and decides that the message is bad, so it makes the body hurt. Then we learn from it and try not to do the same thing again. Like for you, falling off the monkey bars.
But why does the brain has to make it hurt? It doesn't feel nice.
Pain feels bad because the brain wants you to get some rest so that the other cells in your body can fix up the boo-boo before you play again.
Oh, okay. I'll go take a nap and rest until my boo-boo feel better then. Hey, that looked like it hurt. Why you do that?
I don't know. Makes me feel a little better.
You may have convinced yourself you're feeling better, but what you're doing is using physical pain as an outlet for emotional pain.
Emotional pain? What's that?
When you're feeling sad or hurt or angry, those negative emotions can pile up and produce a lot of negative thinking. You start to feel worthless, unhappy all the time.
Yeah, I've also been having trouble sleeping, and I don't watch movies as much as I used to.
You're exhibiting symptoms of what is called major depressive disorder or depression. By engaging in activities of self harm, you're using unhealthy ways to cope with your emotional pain. What you need to do is talk to someone you trust or a health professional. Emotional pain should be taken just as seriously as physical pain because it has to do with your brain. Your brain contains cells called neurons. These neurons are like messengers that form an enormous map, and from one end, the dendrites, they receive messages, and from the other end, the axon, they send messages. These messages can come in forms of little molecules that are released from an axon to a dendrite. The molecules in your brain that may be depleted are the neurotransmitters serotonin, dopamine, and norepinephrine.
What does that have to do with anything?
Well, serotonin, for instance, is heavily involved in regulating your mood. When you don't have enough being exchanged between neurons, your mood is unregulated, and you get these negative feelings that stay negative, which is not normal for a healthy brain.
So, you're saying I feel emotional pain because my brain is unhealthy and not normal?
Emotional pain is perfectly normal. If your boyfriend or girlfriend dumps you, you'll feel emotional pain. But when that pain persists for at least 2 weeks and you have problems with sleep, appetite, motivation, that's when it's become abnormal. Here, I'll be with you on your shoulder when you go tell your parents, okay?
Okay.
I have a test for my bio class tomorrow, but I don't understand this part.
Well, what is it about?
It's about the pain pathways in the body.
Oh, I learned about that. Let me help you. Imagine you just stubbed your toe. The first sharp pain that you feel is caused by A delta fibers, small myelinated fibers that send messages from nociceptors or pain receptors very quickly. Then, the prolonged aching pain in your toe is caused by C fibers, which are large and unmyelinated.
Now I remember. This is related to the gate control theory of pain, right?
Yeah, without any pain stimulation, both fibers are quiet, and an inhibitory interneuron blocks the signal in the projection neuron that connects to the brain. The gate is closed. With the painful stimulus, small nerve fibers are activated, causing the projection neuron to fire while simultaneously blocking the inhibitory one. Thus, it can't block the output of the projection neuron and the gate is open, giving us pain. Depending on where you're hurt, the stimuli travels on different neural tracks. If the pain signal comes from your lower body, it travels to the lumbar spinal cord and then to the primary somatosensory cortex. If it's from your upper body, it goes to the cervical spinal cord, then somatosensory cortex. Another cool thing I learned about pain is the SCN9A mutation. It's basically a mutation of the sodium channel gene, and if you have this, the nociceptor that you mentioned won't be able to fire action potentials.
Oh, so if that happens, you won't be able to feel pain at all. There's so much to know about pain. It's so complicated.
Yeah, it's a pain to study all this.